Hello everyone. In this session, let me solve two more examples of bisection method. Here I have a problem. You have to find the root of the equation x cube minus 5x plus 1 is equal to 0, and we have to use 5 iteration to solve this problem. Now I have already told you I have to take given polynomial as f of x. So f of x is equal to x cube minus 5x plus 1, first step. Now I have to give values for x so that one value should be positive and another value should be negative. First let me give x is equal to 0. So I'll get f of 0 value wherever x is there, replace it with 0. So 0 cube 0 minus 5 into 0 plus 1 is 1. So I have obtained positive in the first step itself, so I can write it is greater than 0. Next I have to check for x is equal to 1. So when I give x is equal to 1, f of 1 value will be 1 cube minus 5 into 1 plus 1. So after simplification, you are going to get 1 plus 1, 2 minus 5 is minus 3 is less than 0. So I can stop here itself. Why? Because I have obtained one positive value and one negative value. So clearly I can write the statement, hence the roots lies between you have to write x value, particular x value 0 and 1. While looking at the sign, you have to look for f of x values. While substituting, you have to take x values. Fine. Roots lies between 0 and 1. Now as per the procedure, first value let me take that as 0 and second value 1. Fine. So what is the formula? Xn is equal to a plus b by 2. So 0 plus 1 by 2 is 0.5. So you have to take that value as, say, x1. x1 is equal to 0.5 I have obtained. Now anyhow we are not interested in x values, we are interested in f of x values. Now what I'm going to do is I'll calculate f of x1 value, that is f of 0.5. So wherever x is there, replace it with 0.5 in the given polynomial. So 5 into 0.5 plus 1. So I'll use calculator. 0.5, since you have a cube here, you have to use bracket, whole cube minus 5 into 0.5 plus 1. So in the single line I have obtained the answer as minus 1.375. Fine. So anyhow we are not interested in the value obtained, but we are interested in the sign. So I have obtained negative value for x1, that is 0.5. So I have given x1 value as 0.5, so that I have obtained f of x value as negative. Now look for the preceding step where I have obtained positive value of f of x. So here I have positive value of f of x when x is equal to 0. Now again the statement, hence roots lies between what it is 0.5 and x is equal to 0. Fine. Now do the same procedure. Let me take a as 0.5 and b as 0. Calculate x2 value. x2 value will be 0.5 plus 0 divided by 2. So it will be 0.25. Clear? So x2 value is 0.25. Anyhow we are not interested in x2. We have to find 0.25 f of x2 value. So wherever x2 is there, we have to replace it with 0.25. So 0.25 whole cube minus 5 into 0.25 plus 1. So after simplification, 0.25 whole cube minus 5 into 0.25 plus 1. That will give us 0.234 minus 0.234 I have obtained. So anyhow it is less than 0. So I have obtained again negative value. Now I have to look for the previous positive value. Is again 0. Why? Because f of 1 is also negative. And f of x1 is also negative. F of x2 is also negative. We have to look for the positive value of f of x, and is f of 0. So the roots lies between x value is 0, right? 0 and 0.25. Now first value a and second value 0.25. So x3 value will become 0 plus 0.25 divided by 2 by using the formula. 0 plus 0.25 divided by 2 will give us 0.125. Now x3 value will become 0.125. Fine. Now I have to find f of x3 value. 0.125 whole cube, replace x with 0.125, that's all, plus 1. So let me simplify. 0.125 whole cube minus 5 into 0.125 plus 1 gives us plus 0.376. That is positive value. Now look for the next preceding value, just preceding step where f of x is negative. So f of x2 is negative, right? So x2 value I have to take. Now x3 value is 0.125. Clearly I can write the roots lies between 0.25 and 0.125. Fine. Now I have to take first value as 0.25, b as 0.125. Now x4 will be 0.25 plus 0.125 divided by 2. 0.25 plus 0.125 divided by 2 will gives us 0.1875. This is the value of x4. Now let me find f of x4 value. Replace x with 0.1875. So you will get 0.1875 whole cube minus 5 into 0.1875 plus 1. So after simplification, 0.1875 whole cube minus 5 into 0.1875 plus 1 will give us 0.069. Anyhow f of x4 value is positive, right, greater than 0. Now I have to look for the previous f of x value which is negative. Since f of x3 is positive, we have to go previous, that is f of x2 value is negative. Negative. Since I have obtained positive, we are looking for negative value and it is for x2. So I can write roots lies between 0.25 and 0.069. Let me take first value as a and second value as b. Now x5 will be 0.25 plus 0.069 divided by 2. 0.25 plus 0.069 divided by 2 will give us 0.1595. This is the value of x5. Further, no need to find f of x5. Why? Because I have already reached x5. They have asked to find the root by using 5 iterations. So that is what I have done. Fine. Now let me repeat once again. First step, we have to take the polynomial as f of x. Next, we have to give values for x right from the least value. So when you have to get one positive number and one negative number up to which you have to give x values. Since in this problem I have obtained first value as positive and the second value as negative, so I have stopped here itself and clearly the roots lies between those two x values. Fine. Now I have used bisection formula given by xn is equal to a plus b by 2. After simplification, since it is first iteration, I have chosen that as x1. Next I have find f of x1 value when x is equal to 0.5. In the given polynomial, replace x with 0.5. After simplification, I have obtained the negative value. Now I have to search for the positive f of x value. Positive f of x value is when x is equal to 0. So I can write the root lies between x is equal to 0 and 0.5. Now let me take first value as a and second value as b. Substitute in bisection formula, you will get x2. Now we are not interested in x value, we are interested in f of x value. So replace x with this value, you will obtain a value which is negative. Since I have obtained negative f of x value, we have to search for the positive f of x value. Again, it is for x is equal to 0. So clearly I have written the root lies between 0 and 0.25. After simplification, I have obtained x3 value. Again, I am repeating the same procedure. So you have to follow the same procedure until the iterations given in the problem. Since here 5 iteration is given, so we have to stop at 5th iteration. That is, we have to find up to x5 value. Clear? Now let me solve one more example in this bisection method. Here is a problem. We have to find the root of the equation x cube minus 9x plus 1 is equal to 0 up to 5 iteration. The same procedure we have to follow. We have to take the given polynomial as f of x. F of x as x cube minus 9x plus 1. Now keep on giving values for x right from the minimum. X is equal to 0. When you give, you will get 1. 0 minus 9 into 0 is 0. So plus 1 you will get, it is positive. So next value we have to search for negative. Let me give x as 1. So when you do that, 9 into 1 plus 1. Right? Plus 1 is 2 minus 9. 2 minus 9 will be minus 7. It is less than 0. So one value is positive, one value is negative. So roots lies between 0 and 1. Clear? Now in the next step we have to find, let me take value as a and let me take b as 1. Use the bisection formula given by xn is equal to a plus b by 2. After simplification, you will get the value of x1 is 1 by 2 is 0.5. So x1 value I have obtained 0.5. I have to use x1 value to find f of x1. Wherever x is there, replace it with 0.5. Clear? Now simplify the expression. 0.5 whole cube minus 9 into 0.5 plus 1 gives us minus 3.375. Again it is negative expression, negative in the sense less than 0. We have to search for the previous value which is positive, is x is equal to 0. So roots lies between, clearly write, roots lies between 0 and 0.5. Take the first value as a, second value as b and substitute in the formula, bisection formula. So you will get x2 value as 0.25. x2 is given by 0.25. Fine. Now f of x2 value I am going to find 0.25 whole cube minus 9 into 0.25 plus 1. So let me simplify this. 0.25 whole cube minus 9 into 0.25 plus 1. 0.25 whole cube minus 9 into 0.25 plus 1 will give us minus 1.234. Again it is negative value. We have to search for the positive value. We have to find up to 5 iteration. In the sense our aim is to find x5 value. So previous positive value is for, again x is equal to 0. Therefore I can write the roots lies between 0 and 0.25. Now let me use the formula to find x3, that is bisection formula given by a plus b by 2. So when you divide this you will get 0.125. So x3 value I have obtained 0.125. Now let me find f of x3 value. So 0.125 whole cube minus 9 into 0.125. I am substituting in the given problem. So let me simplify. 0.125 whole cube minus 9 into 0.125 plus 1. 0.125 whole cube. See, while calculating, if you miss one bracket you will get syntax error. So while calculating please do concentration on typing numbers. So after simplification you will get minus 0.123. Anyhow it is negative. Now again we have to search for the next previous positive value. Again is x is equal to 0. Therefore the roots lies between 0 and 0.125. Now let me calculate x4 using bisection formula a plus b by 2. I am using bisection formula, so it is same for all. 0.125 divided by 2 will give us 0.0625. So x4 value is positive. Now I have to look for the previous negative value since f of x3 itself negative. So the roots lies between, what we have done is only x4, right? We have to simplify f of x4 now. Please concentrate while simplification. So f of x4 will be 0.0625 whole cube minus 9 into 0.0625 plus 1. 0.0625 whole cube minus 9 into 0.0625 plus 1 will give us, anyhow it is also positive, but you have to check for it, 0.4377. It is positive value. Previous negative value is f of x3. For x3 is equal to 0.125. Therefore I can write the roots lies between 0.125 and 0.0625. Again I am using formula to find the value of x5. 0.125 plus 0.625 divided by 2 is 0.09375. I am repeating once again. First step, we have to choose the given problem as f of x, give minimum values for x, so that first value will be, one value will be positive and one value will be negative. Fine. So now here in this step f of 0 is positive, so f of 1 is negative. See here, f of 1 value is negative. So I am going to stop here itself. Now we have to consider x values and substitute using bisection formula. First value will be taken as a and second value will be taken as b. So in the first iteration I have obtained the value of x1. Fine. Anyhow, we are not interested in x1 value, so I have substituted that x1 value in a given function so as to obtain f of x1 value. Since f of x1 is negative, now similarly I have to search for the preceding value which is positive. So f of x1 is negative, so f of 0 is positive. So clearly the root lies between 0 and 0.5. First value is taken as a and second value is taken as 0.5. So substitute in the bisection formula, I'll get x2 value. Similarly, let me find f of x2. Wherever x is there, replace it with x2 so that I have obtained negative value. So we are interested in the positive value of the preceding f of x. Since f of x1 is negative here, let us look for f of 1. Again it is negative. So f of 0 is positive for x is equal to 0. So clearly roots lies between 0.25 and 0. So that is what I have written. Now I have substituted, I have taken this value as a and this value as b. I have substituted in the bisection formula continuing the same procedure, that is substituting x3 in f of x. I have obtained negative value. Similarly, I have to go for the previous step where I have positive value. It is for x is equal to 0. So the roots lies between 0 and 0.125. Now what I have done is x4 value I have substituted in given function f of x, so that I have obtained f of x4 value. Again f of x4 is positive. Now we have to search for the negative value. Since in the preceding step, that is for f of x3 itself, we have obtained negative value. So the root lies between x3 is equal to 0.125 and 0.625. 0.125. So again I have chosen first value as a and second value as b. I have substituted in the bisection formula. I have obtained x4 value. So I have substituted x4 value in the given function. I have obtained positive value. Now we have to look for the negative value and it is given by x3. So the root lies between x3 and x4. So substituting in a bisection formula I have obtained x5 value. Now no need to continue further. Why? Because they have asked us to find the root up to 5 iteration. So we have to find x5 value. Since I have obtained x5 value, this will be the required root of the given equation. Hope so it is clear. Thank you. See you in the next session.